Shaaz, Emil, happy to have you in studio. Welcome to our humble little abode. Thanks for your time and your effort in joining me for this podcast. Shaaz, it's basically a welcome back to you, although the previous one that we did was, I think it was via Zoom or Teams, so you phoned in and called in for that podcast. It's lucky to have you in the studio.
Thanks, Willem. It actually feels like a very, very long time, but it was just 2 years. So yeah, good to be back.
It's been 2 years, eh? It's been 2 years since our previous podcast.
Yeah.
It's lucky to have Supahot in the studio because I think the information that you're going to share with us today is lack valuable to our plumbers. We're going to talk about, you're going to give us a little bit more insight on the difference between vertical and horizontal geysers. We're going to speak about geyser efficiency, and then obviously the difference between the different capacities of geysers. So it's lucky to have a brand like Supahot and people who actually manufacture these kind of products on a daily basis and who supplies that to the industry to actually speak on the subject. But so speaking of the fact that it's been 2 years since our last podcast, we've seen since that podcast, we've noticed a significant increase in brand and product awareness among the technicians. And it's so lucky to see that. You must have been doing something right to achieve that, and it makes my heart warm to notice that and to recognize and realize that. But what's been happening in Supahot? What I'm going to give you the floor to tell us what's going to be going on in Supahot.
So it's been a very good journey for us from the time we started in 2019, and then obviously we get into COVID at 2020, and what has happened over the last 2 years is that we've acquired another geyser company, and we've amalgamated the two together and moved to our bigger premises. And so the manufacturing has been and streamlined in terms of machinery, equipment, and upgrading of that equipment in terms of specific the enamel powder coating that we do, as well as the foaming. So there's a lot of upgrades that we did, and I think in terms of why our name is getting out there is, look, we don't spend big bucks on budgets in terms of marketing, etc. Right? We feel that the best marketing is word of mouth.
Yeah.
And I
think the proof is in the pudding.
So, what we've done is we've always just had an open channel to everybody, whether it's a plumber, whether it's a customer, end consumer, whoever it was, homeowner. We have an open channel. If there's something technical that's required, Emil would get onto the phone with the person. So, we don't have that. He's the general manager, so he needs to talk to a manager, and then the manager would then liaise. We don't have that. We've got a straight line operation. We speak to the guys one-on-one, whoever it may be it plumbers, etc. And we've brought our warranty in-house now. Subsequent, we've been running our warranty as outsourced. I think with the acquisition of Frankie, we piggybacked off their intellect, etc., and we want to concentrate on manufacturing. But as we evolved and grew and got stronger and bigger, we felt that we needed to bring it in-house. And so we brought it in-house. And so there again, there's been the one-on-one with the plumber, one-on-one with the customer. And then it's just been word of mouth. And I think it's just service, I think that's all that we've been doing. So we highly focused on being one-on-one with customers, one-on-one with end users, one-on-one with plumbers. I think due to that, the word has been spreading. So it's been phenomenal.
It's absolutely fantastic. I mean, that's one of the key things that drives people to make decisions to which product they're going to use or which brand they're going to use, for that matter, is that engagement and that relationship that they build with whoever supplies them. And it's awesome to hear that that's what you've been investing in rather than spending on millions or whatever.
Yeah. But Willem, the other thing is that, we've certainly had our fair share of problems or mistakes, but we never shied away from it. When we moved our factory from Germiston to Pretoria, we basically split our production in two of certain lines and then moved over half the plant and then the other half, etc. And we had an interim of where we had problems, right, in terms of quality, our foaming, our flange gasket, etc. And we were open to say, guys, pick our hands up. We made a mistake. We had a problem. This is the reason why. But here's the refunds, or here's the replacements. And, own up.
Yes.
Because at the end of the day, we must understand that we are manufacturing. This is not a robot that makes certain things. Although yes, our plant is automated, etc. But you're going to have problems.
Yes.
I mean, Toyota, Mercedes,
They
Porsche,
all do.
Lamborghini, all have recalls at some
Yes.
time or the other to say, bring the car in, we had this problem. So you are going to have those issues, but you must be sincere. And because we owner run, right? And our team takes it as their own and it's all owner run, we just see ourselves as one big family. I mean, from the time we started, we just all together and we have meetings and we have one-on-ones and we take it as our own. And so we put our hands up and we say, we had a problem. And people appreciate that rather than, just duck it under the carpet or blame it on somebody else. You take responsibility and we move on.
Yeah.
So that's one of the core principles that we've worked on.
Speaking of your principles and what you pride yourself on, I know that Supahot prides itself on obviously being a proudly South African product and brand. You mentioned that the factory is here; it's family owned, and it also prides itself in being on the quality of its products. But it prides itself also being on a provider or the provider for the right solution for the right application and the right requirements, and that obviously when a technician or a customer, a consumer needs to make a decision about things, they need to understand all the things that weigh up between this product and that product, or this type of installation and that type of installation. So when you're saying that you pride yourself on being a trusted provider for making the right decision for the right product, for the right application, it's key that those who need to make a decision then understands the differences. And one of those differences and one of those things that they need to understand is the difference, for example, like between a horizontal and a vertical installation. And I did mention in the opening that that's one of the key aspects that we're going to address today.
But I think Emil, Willem's going to get us into big trouble here. So, when we speak of being South African,
yes,
we are really and truly proud to actually say that we are the only proudly South African company. If you look at our competitors, and although they're based in South Africa or the manufacturing processes are in South Africa, they're not owned by South Africans. So, and that makes a huge difference because understand when you're talking of directorship, the director's got to understand South Africa.
Yes.
And the only way to understand South Africa is to be South African. Because our challenges that we have, you can only understand it if you're South African, and the strengths that we draw from each other. I mean, South Africa in terms of KZN had the riots.
Oh, yes.
We had flooding. We had, all these type of things that make us stronger, right? And because we South African, we can understand the resilience and the culture and the nature of our people.
Yeah.
Right? So I know I'm going to get into trouble because we have a good relationship with our competitors, but we are truly South African.
Yeah.
All our competitors are owned by international companies. And so the direction may be very different to how we feel and what we understand of the marketplace and the consumer.
It makes a lot of sense when you say it like that. It's definitely factors that we need to consider when we think of things, and it's a good thing. It's a good thing to hear it as well, and it just boils back to the fact that aspect of understanding. I mean, yes, you understand the people, the challenges in our country, the type of cultures that we have in the country. You also understand our environment. Because our environment may differ from that in Europe. It may differ from that in the Middle East. It may differ from that in the US. And for that reason, the way that we apply things here is slightly different. Our requirements may slightly change.
And to that point, that's why we are so passionate about being a 400 kPa geyser, versus the 600, which was conventional, because we understand as South Africans the climate, we understand load shedding, we understand the electricity difficulties that we face, the cost of living, which is the most important thing on everybody's mind at the moment, and more importantly, water. People open up the taps and just think that everything's okay. what people don't understand is South Africa, in terms of the international survey, is a water scarce country.
Very
and in
much.
the future, I mean, if you look at all the discussions that's taking place and the conspiracy theorists, etc., that wars will be because of water, not oil or gold
Yeah.
anymore. And if we see it in terms of the realities, I always refer to KZN because KZN seems to have just had all the problems that we could ever get. And I'm based in KZN and from KZN, so it's close to my heart. KZN had water problems in terms of infrastructure. So you get areas in the north like Umhlanga, Verulam, Stanger. I mean, just 2 days ago, there was a huge problem in Ladysmith where they haven't had water for 28 days, right? So although people in the Western Cape or Gauteng may just open up the taps and think, where's the water problem? The reality is there is a water problem, and it's not just because of a supply from nature, but it's also because of our infrastructure and our failing infrastructure. So we have to be conservative. We have to look at saving water. And so we put our money where our mouth is. And we could have, our geyser would pass as a 600 kPa. But we didn't want to just give the customer, because you see there's an issue with 400 versus 600 in terms of the insurance industry. So the insurance industry requires you to change a like for like. So in terms of the wording of the policy, they change like for like. So 600 to a 600. What people don't understand is, what is the real difference between a 400 and a 600? You and I would not feel it in our shower, to be honest. I've got 400 kPAs in my home. Emil's got in his home. We've got 400 kPAs, and we don't feel the difference to a 600 kPa, because the municipal pressure itself only comes in at a maximum 3.5 bar at certain areas of pressure. Am I right?
Yeah.
So why have the 600? But when there's a damage, or if that extra 2 bar pressure hits your tank, you got all that water that's going to disperse, and you're going to have subsequent damage. But at the same time, using more water. But Emil will talk, to the technical aspects of that. But I'm just coming to the point of where we put our money where our mouth is.
Yeah.
And we could have went and had a 600 kPa. But we're saying, guys, we are here to look after our environment. It's our country. We got to understand that energy is an issue, water is an issue. And so we are sticking to the 400 to say we want to keep the 400 kPa geyser. So we are changing mindsets by education, such as this. People don't really understand why there's a difference between a 400 and 600. But Emil's got excellent technical knowledge, and he's going to share with you actual data as to why there's a difference.
Let's start with that then. Let's have a look at the difference between the 400 and the 600. What is it, and what are the pros to the one and the cons to the other? And it's not to shoot down any other product that exists out there at all. But let's just have a look at what pros and what cons there are.
Okay, so basically the main difference between 400 and 600 is your pressure inside your tank. So obviously, the bigger your pressure is, the more water pressure you get through your pipes. So they've done studies where they say you use 20 liters of water on a shower. So that's at 400 kPa. Obviously, if you go to 600, you have to add about an 18% water percentage to that. So obviously, when you're using a 600, you're using much more water to do the same function. And the geyser works that whatever hot water you take out, you'll be replacing with cold water, and you have to heat it up.
So energy goes up as well.
So energy consumption and water consumption on the 400 is between 18 and 20% lower than on the 600. So if you convert it to rands and cents, it makes a big difference.
And those are the finer things, like you said, that comes with conversations, educating and informing people through conversations like that, and making them understand the differences when they have to make choices and decisions. I mean, the consumer wouldn't necessarily know all of this unless the technician explains that to them. But the technician then at the same time also needs to understand the difference. I want to ask, just as a layperson, somebody who's not a plumber, if the municipal pressure is 3.5 kPa, then would the 600 kPa geysers still push that amount of volume through?
So on average, I've done tests on your pressure valves. So it says it's a 600, but your safety factor works in, so it's about 5.5. So a 400 drops to about 3.5. So anything above 3.5, the pressure valve will reduce the pressure into your tank. On a 600, you're still going to get 5.5 kPa, 500
coming through the pipes.
through to your pipe. So it's still a higher pressure.
Sure.
So you're still going to use more water, and your
Electricity.
is going to definitely, you'll see the difference. Like I said, on a day-to-day basis, you're looking at 2-3 rand, but add it to your
a
monthly
month
bill,
and a year.
and the calculations is per person. If you're a family of 2, family of 3, you have to multiply it. So then your costs there's a major difference between.
And I can tell you for certain, if somebody's got a 600 kPa in their home, they're not going to stand under the shower longer. You go and stand in the shower, whether you're 400 or 600 kPa, you do what you need to do in the shower, and it takes you that amount of time, right? I mean, I've got a child, just one of my 4 kids, and that child specifically just stays in the shower for much longer than everybody else, right? So they just do what they need to do in the shower at that time. So for that period, you're losing that 18 to 20% of water.
Yeah.
Now, also, you know what Emil's talking about, the 3-4 rands a day, that's only on the water. What about the electricity to heat up?
Yes.
So it's actually, like you're getting very close to your 10 rand a day, So we've got actual studies and we've got actual calculations which really justify, that backs up what we say, which isn't dumb like this.
But let's get now to, okay, so we've discussed the pros and cons versus a 400 versus a 600. But let's talk about then directly, let's let that flow into energy efficiency and how your products achieve that. How do you achieve that with your products? I know that there's a lot of things that you do. There's a lot of changes that you've made to your products that make your products a little bit more or significantly more energy efficient.
Okay, so we've got the guys that supplies us with our foam. They brought us a new mixture of chemicals about last year.
You're giving our trade secrets.
A better mixture.
Our competitors are going to be on.
Where we saw that we had about a 10 to 15% increase in our insulation just by changing the formula of the chemical. So, like I said, my aim is to make an A-rated geyser. So, yeah, we're working on that. The thing is with your foam as well, there is a formula where at 60 mil, you get X amount of insulation. So if you double it to 120, you don't double your insulation, you get a quarter more insulation value, but your cost triple.
From a manufacturing perspective, yeah.
So there is a sweet spot, and I think we're dead on it. We're dead on.
Yeah.
But certainly that's not the only thing, is that?
Oh, yeah. So look, the most important thing which we stuck by, and it costs more money, is that we are the only geyser that has galvanized end caps. And galvanized end caps, I mean, just from a common sense point of view, steel retains heat better than plastic. If you hold a plastic cup or you hold a metal cup with something warm inside, which one will retain it better?
Exactly.
It's definitely going to be something metal. And there's studies that has happened. Emil worked very closely on those studies. I'll let him talk to those studies on the galvanized.
So yeah, on your plastic, your insulation value of the plastic is almost zero. Where your galvanized gives you a better insulation value, which then translates to your geyser stays hotter for longer. So that's why we stick to galv. It's stronger and it gives us a much better insulation value.
Heat retention,
Yeah, heat retention.
And this study was actually done at the Stellenbosch University.
Oh, lekker.
And you actually see, so they taken, what's the gun?
Infrared. So it's a flare.
So they take the flow gun, infrared gun, and they basically shoot it onto the plastic and to the galvanized end cap and different types of caps. And you can see which one is red, which one is amber, which one is, light yellow. And the galvanized end caps stand out as the coolest from all the other products.
Yes.
So yeah.
Is that some of the diagrams that you've got in front of you now?
Yes.
Because I think that what's nice, what we can do is maybe slot that in, and our editor
you should.
can.
In fact, if you look at it, I mean, this is the colors that we were talking to.
There's a big one.
Yeah.
Big one's not there.
I think we'll, as we speak to them,
Yeah.
we'll ask our editor to just bring it in so that our viewers can also see
Correct.
that.
So obviously,
if you can see this one is hotter and this one is colder. You can see the
this is
amber.
the complete galvanized, or the dome.
Yeah.
And then obviously the competitor's plastic. You can see the heat
My goodness.
coming through the plastic. Which
Yeah.
Scalf keeps it.
So again, coming to the point of, we're putting our money where our mouth is. I mean, plastic is cheaper than steel. It's just is. And we have so our product costs us more, but yet we found that we are passing that over to the customer. And so our pricing is still keener than the other products in the market. But that's again coming to the point where we're putting our money where our mouth is. We've got we honestly just working on having the best geyser out there in the market from the consumer. I mean, plastic looks nice. It's pretty. You mold it in the shape that you want. It looks all high tech, but practical. What is practical?
Yeah.
What works? The steel works.
Again, it boils down to our needs and our circumstances within our country.
Exactly.
Exactly. That you keep on reiterating the fact that yes, we are a water scarce country and we have massive and drastic problems with our energy supply. And any product certainly that can contribute as a solution to that, or at least a reduction to wastage of it, or over expenditure or over usage of it, is a very welcome factor. It's a very welcome product. So it's lucky to hear that in the back end, your engineers and those who sit and develop your products actually sit and consider these things and take that into consideration. And I'm sure, yes, competitors would do the same. But it's lucky to hear that when somebody who provides a product to a customer has taken a lot of things into consideration, rather than just putting a product on the table that can heat their water for them or something like that. So,
and it's not also about looks, I mean, we got to be practical. I mean, a geyser is a geyser. No matter how pretty you want it to look, it needs to be functional.
yes.
So that's what we're just looking to do, is having a functional geyser to save the electricity, save the water, and give us, the unique thing is South Africa is very unique again, in that not many other countries use a geyser. If we talk to anyone international and you tell them, what geyser do you have in your home? Like, what are you talking about? They don't even use the word geyser. To be honest, try that.
They what water heaters?
They use water heaters or they use boilers. Right? They don't use the word geyser. I mean, I speak to people all over the world, and you use the word geyser, they're like, what is this? What are you talking about? Then you got to explain to them and sometimes show them a picture, So we're very unique.
Yeah.
If you take Europe, or if you take the UAE or one of the, Saudi or Egypt, etc., they have in each room a small, like an instant heater.
Yes.
In each room, in each bathroom, they'll have that. They don't have this big boiler system. Some houses may have, but many a times when you go to these places, you'll find that in the guy's house, he's got one in the kitchen, one in the bathroom, one in another bathroom. You think to yourself, okay. But again, they don't have those extreme heats, etc.
Yes.
So South Africa is unique in the way that we use our product. If you take Europe uses gas and they have a boiler into the entire unit. If you take Turkey, for example, I mean, there's a block of flats which I saw. They've got these boilers that feed the entire unit through gas.
Yeah.
Right? And South Africa, again, doesn't have that.
Yeah.
Many other countries in Europe or the States, for example, have these big boilers in the bottom of their houses or in the back, and they're big boilers, like these 300-liter boilers, and it feeds into the entire house. Very different to us. And again, it comes back to the spend.
Yes.
I mean, not everybody can go in and put a 28,000 Rand of these boilers into their homes. 4,000 ex VAT, 5,000 ex VAT, yes, people can afford that. When you're talking of that amount of capex, it's high. The end user just can't do it. And, ultimately, it's going to need to be replaced. You don't have the geysers of what used to be back 20 years ago, 30 years ago, when copper prices were low and geysers were made out of copper,
Yes.
Those days are over, So you got to use this technology, and ultimately you are going to be replacing your geysers in your lifetime a few times, but you want to be able to have it cost at a replaceable cost that fits your pocket. Yeah.
But speaking of newer technology, and then we come to the conversation that we had off air, Emil, about the between a B-rated and a you said you're aiming for an A-rated, but a D-rated and a B-rated geyser. And off air we spoke about an interesting concept and an interesting idea, because this is a debate that many people will have. Technicians will have it, consumers will have it, and you'll hear various opinions about it. But somebody said to me, you know what, it's actually more energy efficient, for a lack of better terms, cheaper, to keep your geyser on 24/7 instead of having it only come on for an hour at 1 o'clock in the afternoon, and then again a half an hour at 7 o'clock at night or something like that. Is that true? Is that a true concept that it's more efficient, or can be more efficient, to just keep it on running 24/7? And how would you explain that?
Okay, so in the olden days, when you had the D-rated geyser, your heat loss through your system was massive. So you lost 3-4 degrees of water temperature per hour. Now, obviously, we moved to the B-rated, where it came down to 0.4 of a degree per hour on heat loss.
Sure.
So now your biggest factor there is, if you switch your geyser off for 1 hour, you lose 0.4 of a degree, which is, you're not even going to notice it or feel it. But when you switch it back on, you have to heat up 150 liters by 0.4 of a degree.
Yes.
And
only
that uses
0.4 of a degree.
That uses energy. So if you look at the energy efficiency my energy efficiency of the unit, you use 1.3 kilowatt hours in a 24-hour cycle. So that's how much power a geyser uses to stay hot. So if you break it down per hour, you're going to use 0.2 watts or kilowatts to keep your water warm. But to heat up 0.4 of a degrees on 150, you're going to use more. So on average, you're looking at it, switching off, it's going to cost you 20 cents per hour more than just leaving your geyser on.
But I just want to add to that. Firstly, there was big hoo-ha, because when we joined the industry, we actually joined into the period where you had to move over from a D-rated to a B-rated. And when we did the acquisition of Frankie was on a D-rated geyser. So we thought we were just going to continue. And the regulations kicked in, and we had to move to a B-rated. So we had to change the design of the geyser, etc., to accommodate the thicker foam, etc. But, people at times always there to criticize government, right? And I would really, turn a spin on this. We actually should look at how government made the B-rated geyser, changed from a D-rated to a B-rated geyser. And you've got to take your hats out to them and give them the credit for that, because they foresaw something in terms of the energy, because the geyser uses 30-40% of your home usage, right? In terms of electricity consumption. So they really saw that, and they made the change, and they, dug their heels in and said, we're going to a B-rated. If you take our competitors out there, they welcomed it, which was good. We could have always argued with them or taken them to court or did all those things, and they didn't. So it was a good migration to them. So I just wanted to take that opportunity to actually give credit to our government for actually foreseeing that, the Department of Trade and Industry and the Energy Ministry, for changing that. So it was a good thing. But, as a common person, if I look at it just as common sense, to heat up, or to the question, you got a cold start and a warm start. So if you want to go and heat up your food, right, in your oven, not the microwave now, in the oven, if your oven was already warm, what would take faster to get to that temperature? A warm oven or a cold oven?
Obviously the warm oven.
The warm oven.
Yeah.
So that's the point that Emil is making, rather than having a cold start, because you're going to use more electricity to heat up the tank, on a warm start, it's going to use less efficiency. Yes, if you're talking about a 3-day, you're going on vacation or you're going away, then you put your geyser off. Okay, that makes sense. But for the few hours, 5, 6, 7 hours, doesn't make any sense, because the water's already warm in there.
Your biggest problem there is as well. So you take your morning shower, you switch it off.
And then it's cold.
By this afternoon, when you get home, you're in peak time and you switch it on.
It's what happens to me.
So that's defeating the point of trying to save money, because your peak hours cost you more.
It's literally like that with me, because I have a timer on my geyser. And what happens to me is I take a shower in the morning, and then I immediately go and switch it off, because I had it on for that half an hour just to quickly heat it up or whatever. And then I immediately go and switch it off before I leave for work. So now the water that I used gets replaced with cold water. So if I used X amount, that's X amount going back into the geyser, that when I switch it on at 7 o'clock at night, when I want to take another shower, now all of that, and the temperature loss.
Now you got a cold start.
Yeah.
It actually makes sense. But, as a consumer, again, I'm a consumer, I'm not a plumber, I'm not a technician, and I'm not a manufacturer of these kind of products. So, it's interesting then for me to hear it from the horse's mouth, from somebody who actually manufactures these and who go and sit and does the research and actually look at things and take things into consideration, because there are many debates about it, and many consumers and customers will tell you, yeah, but this and yeah, but that, and I heard this and I heard that. So it's lucky to hear from guys like you.
One of the other things that we want to educate, the community about is a vertical versus a horizontal installation, right? But I want to give you a real life example, okay, of myself, a personal experience. So I was in Durban, moved to a home, and I wanted my geysers to be installed vertically. And my geyser was installed horizontally, right? I didn't know. I just told the plumber, install it. At that time, we started manufacturing our geysers, so I was excited to put Supahot geysers inside, right? So in my guest room, which or that geyser that sees to 3 bedrooms, I had visitors over, and the water was getting cold. So they were having showers, and we had to wait for them, especially when you got guests over. I phoned Emil and I said, the geysers are getting cold very quick. It's a 150-liter geyser. I think I should put a 200-liter. So he says, how did you do the installation? So I'll come back to you. I went outside, I checked the geyser, it was horizontal. Right?
Okay.
So I called the plumber and I said, but I told you to do it vertically, because Emil did such an amazing example. It's just common sense, right? But I'm going to let him talk to you about why he does it. I'm just giving you my real life example.
Your own experience.
So he came in and he changed the geyser from a horizontal to a vertical. To date, those 3 bedrooms never run off hot water. It's fine. I didn't need to put a 200-liter. And then Emil explained as to why, when you got a horizontal and a vertical, actually on a vertical you got 100% water, and on a horizontal you only got 60% hot water. But he's going to explain why.
I love to hear.
So the studies that the clever people also done, it shows that if your geyser is installed vertical, it's more energy efficient than horizontal. For some reason, I was still looking at the
element.
I was looking at all the study material, and so basically, when you're horizontal, your cold water flows into your tank, and it flows into the length of your tank. So your tank is basically
as an example, your element sits in the middle.
So your water flows in, all your cold water goes into the bottom. Your element heats, so your top half of your water is hot, the bottom half is cold.
All right.
So as soon as you do this, your element sits in the bottom. All the hot water raises to the top. So the cold water coming in stays by your element, gets heated faster, and keeps your
tank. So you've got 100% of hot water versus having only the top part of 60% hot water. So what that means is that you're using less electricity, because your geyser is not heating up that much. Yes, your first heat, which is when you first do your installation, will take long. But thereafter, your thermostat's not kicking in that many times, because your water is being hotter, because you've got a full tank of hot water.
From a manufacturer's perspective, does any modifications to design of the product need to be made to make it compatible either horizontally or either vertically? Or can it be installed in either directions?
So
our unit is designed. It's got the 4 ports, so it's already solar ready. It's horizontal, vertical, wall mount. It's a custom made. It's ready.
Yeah,
whatever you want to install it,
it's done.
The unit is ready to.
But a lot of our manufacturers have the same. So in
Yeah.
terms of the ports, etc. So it's not you don't have to change anything from a manufacturing point. It's just that the installation where you would use a solar port. So if Willem wants to put an electric geyser in his home and run it on electric, there's a solar port that's available for him if he wants to add a solar panel, okay, or a heat pump. So they would use that port for your vertical installation. So where ordinarily, if you did a horizontal installation, your hot water outlet is from the top.
Yes.
Now all you do is that, and where your heat pump was, you'd use that port for your outlet.
My goodness.
So it's already there, but people don't know. And you know the funny thing is when I asked the plumber, I said, why did you install it this way? Like, why do you install horizontally? That's how we've been trained.
Yes.
You know, that's how geysers are. And when you explain it to them, like, oh, yeah, you're right. It's such a simple common sense thing, but it's the education drive.
Yes.
People don't know about it. And like whoever I speak to, I tell them this, and they're like, yeah, you're right. Huh? And then all of a sudden they get the plumbers to come in and change their existing geysers to vertical installation. Might use a little bit more pipe work, but the cost savings is definitely there if you do vertical.
That's very, very interesting. I mean, to again, it boils down to the fact that the average person don't even take these kind of things in consideration. The average consumer wouldn't know this. And again, it boils down to the technician should, so that the technician can make those the suggestions and give that type of advice to the consumer, the customer, and educate the customer and say, but if we do it this way, you'll use less electricity.
And we've, of the last few months, if not a year, have now put on stickers onto our geyser, which has the installation of both horizontal and vertical. And where it says vertical, we actually say recommendation, to do it as a vertical installation. So that's now on our geyser.
Listen, but Emil, speaking of your geysers, I know that you brought, is it one that's cut in half or...
Yeah, it's cut open basically, so you can see the inner workings.
And I know that you've got a couple of things that you would like to share to show it to our viewers who are viewing this episode, and a couple of things that you would like to say about that when you do your presentation, so that our audience who are listening can also have a listen to what you're saying. So I think let's do a quick setup to do that demo. And then we'll return and do a closing because we are running out of time. Like all good things, all good things have to come to an end. So I think let's do your presentation quickly, Emil, and then we get back to closing off the episode.
Excellent.
Good. Okay, so this is our 150-liter geyser,
Right.
which we basically did a cutout to show you the inner workings of your geyser. On your left-hand side, we have the element. It's a 3 kilowatt. The reasoning about a 3 kilowatt element is the efficiency to heat water is a constant. So you can basically put in a 6 kilowatt if you want. Your energy consumption will stay the same. Just the time delay to get your water to temperature is faster. That's one interesting fact. So element size, 3 kilowatt, perfect for 150 liters. You're looking at about an hour and 10 minutes from cold start at 20 degrees till running temperature.
Speaking of, I'm interrupting you now, but speaking of your element, wasn't it that the gasket was made in such a way that it could be used with universal type of elements? So
the gasket was designed, we changed the design to a natural rubber.
All right.
So basically, on that gasket, I'll give you a lifetime warranty. The natural rubber with the heat, with the water, outlasts everything else. So if you take that, the gasket itself, it does universally fit onto, competitors' units as well. But our gasket is superior to my opinion.
But it's a good thing. Take pride in it, man.
So then obviously the second part of that makes your geyser efficient is the thickness of your foam. So I've got a 65 mil thickness on my body, which goes to about a 75 on my domes. So that gives you the B rating, it gives you the energy efficiency, and it retains the heat inside your tank. Then part number 3, you can see the 2 anodes. So we added an anode to better protect the tank.
Sure.
It's actually wrong to say to protect the tank. The water quality, everybody knows.
Yeah.
I can't remember when last I had water out of a tap.
It's just not reliable anymore.
Yeah. So basically, to protect the unit, we inserted a second anode to protect the integrity of the unit.
I know that you also did some tests on tanks where you did it one with it and one without it, and you explained to me off air before we started recording. You said to me that the one eroded much quicker than the other.
So basically my tests was I did bare metal tanks. So it's pre-coated bare metal with an anode, and then with the dual anode. And the dual anode, after about 2 months of testing, the sheet metal was still silver. There was no corrosion, nothing on the bare metal. Where the magnesium started showing signs of being eaten away, protecting the metal, obviously. And then the one without any protection was rusted completely.
Sure. And that's your own, you also made them longer.
Yeah. The standard anode, we increased about 100 mil on each. That gives you that little extra protection. So on bad water areas, farms, plots, it gives you that little bit of extra confidence in the unit.
And then we were speaking, when we were at the table, we spoke about the horizontal and the vertical positions and where your in and outlets would then be. Where are those then?
Okay, so on a standard horizontal, this would be your outlet.
Right.
Safety valve on top. So basically when you put it vertical, you can either put your safety valve on your standard outlet, or there's a dual port for the safety valve on top with your outlet. So it's got a dual position, which makes it easier for the installation.
And then also, as we put this onto this little trolley here, you showed me, Shaaz actually showed me this clever little thing here on the side where your TP valve is, because I thought I saw the anode of a TP valve here, but I was unsure of what I was seeing. So I actually asked, and he said to me it was just a clever way of storing it until installation,
yes, definitely.
which is quite clever.
Yeah, we had issues previously. So with it being inside that cap, you can, when you buy the unit, you know all your components that you need are already installed onto the unit.
And then obviously we spoke, when we sat at the table, we spoke about the galvanized end caps, which is an important thing. I mean, we saw those diagrams of the heat spread and how the heat gets lost through plastics more quickly than what it does through your galvanized. And these are them.
Okay, so basically, firstly, mechanical strength. Secondly, insulation value. So you've got a much less or a lesser heat loss through your galv than you've got through plastic. So that's why we stick to galv.
All right. And then obviously I can see the blue, the enameling on the inside. And that's also one of the changes that you said that you made.
The major changes on your enameling is the way it's bonded to your metal. So basically we use an electrostatically charged powder that basically gives your body a negative charge your powder positive, and that causes the powder to stick to the metal. From there, we put it into a furnace or oven, big oven, and we bake it for 840 degrees for X amount of time, which basically turns your powder into a glass covering. It's virtuous enamel, it's physically glass. So that glass then gets bonded to your sheet metal.
Oh, wow.
So there's a solid bond. And then obviously in production, we do thickness micrometer tests on the units to make sure we get the correct thicknesses right through your entire tank for the best optimal protection.
Emil, thanks for this. Lucky to see the product. It's lucky to see one that comes out of the factory, and it wasn't prepared for a podcast. It was actually one that you selected.
Yeah, no golden samples
from your lines.
It's from the line, yes.
But I appreciate you showing it. It's also, I'll say it again when we sit down at the table. But it's nice for our plumbers to actually see something in front of their eyes. Hence the visual aspect to our podcast. And I want to appreciate you bringing this with and demoing it in the studio.
It's a pleasure.
Let's go close off this episode.
Cool.
Awesome, Emil. Thanks for that. I mean, like I say, it's always interesting for our plumbers, especially that's why we brought in the camera and the visual aspect to our podcasts. It's lucky for them to see the product as it's being explained, to see that thickness of the layer of the foam, to see where the anodes are, to see the end caps that are galvanized and those kind of things. So thanks for that. And I think thanks for the information that you shared with it as well. And yeah, it's coming to a close of the episode. And I want to thank you, the both of you again, for the effort you put in to drive all the way here to our studio and to come and share this information. And I want to reiterate the word that you keep saying or keep using, Shaaz, is that educate. It's to educate our plumbers. They're never too old to learn, and there's always something new that they might not have known in the past. And again, it boils down to, we spoke about the differences between the old and the new. When you had galvanized pipes in the old, now you have copper pipes. You had D-rated Geysers in the past. Now you've got B-rated, and you're aiming for an A-rated. So there's always new things, new innovation, new technology, new methods. It was interesting, without giving away too much of your IP about what goes on in your factory. It was interesting to hear that you've taken new things, especially considering studies and research that have been made. And I'm babbling, but I want to say to you, just a quick recap of where the plumbers, where our technicians can actually get your stock. Things like after sales services, if they need assistance from you. You did say it's direct from the top engagements with the plumbers and the technicians. And any last messages that you would like to leave our audience with?
Look, just to answer the question about warranty and stock. So our product is in most retail, independent, and chain stores. You can find them literally at any hardware store. In terms of our warranty, we've got a warranty call center, which is on our website. It's on the Geyser. We've got a WhatsApp line, we've got a cell line, and we've got the landline. So, and an email address. So it's very, communication-wise, you can get in touch with us anywhere. And if you just go to www.supahot.co.za, you're going to find out whatever it is that you require. But Willem, I want to thank you for actually allowing us the opportunity to have this platform to explain our product and to get the word out there and educate people.
Yeah.
And, back in the day, you only had leaflets which you would leave at a store. Today we've got podcasts, etc. And the initiatives that you guys are taking is great. So we want to thank you for always allowing a fair playing field for everybody. And once again, thanks for everything that you've done for us.
Only with pleasure. Emil, any last words from your side? What should our plumbers and our technicians consider when they...
Support.
Yeah, support. There we go. Yeah, like I said, it's your customer base. That's where the main education needs to come in on your rands and cents on your unit, the efficiency rating, your water consumption. Like I said, everybody says the Geyser is your most expensive electrical unit in your house, and it's all based on consumption.
Yeah, and
so it's a consumption-based cost.
Yeah, and understanding that is key to the kind of advice that you give to and the kind of solution that you provide as a technician to your consumer, I'd say. So yeah,
a couple of simple things you need to change your position horizontal to vertical, and it will proof is in the pudding.
Yeah, and choose your products well. Shaaz, Emil, thanks a stack. Much appreciate your time and the valuable information shared.
Absolutely. Thanks for that.
Thanks.
Awesome.